Hello. Ever since I was a little kid, I have always wondered how the computer actually works. Like, how does it understand this text that I'm typing into it? How am I even typing this text? It seemed like magic, not like the ones in the cartoons, no, like actual, real magic. And you don't really understand what's going on inside this thing. And I tried to research it, and the courses that teach you how to program, they only teach you the surface level, like they only show you the final layer. They don't show you how any of it works, how the CPU actually runs, how it manages memory, what the CPU is made of, what even is a transistor. And I mean, yeah, obviously, it felt really good to write my first line of code and seeing it on the screen and feeling like a hacker finally, or whatever you would like to call it. But it still felt like something was missing. So in this series of videos, hopefully we can take a closer look together. And yes, together, because I'm gonna be learning this as we go along. And yeah, this is a magnifying glass. I'm garbage at art. So let's take a look at some C code. This code supposedly prints hello world, but like, how does it all happen? Just a bunch of dead characters that makes the computer say hello. Okay, so let's take a look at what actually happens when we try to run this program. If we actually take it as it is, like the computer does not understand what's even going on. Those are just some dead characters in a text file. So the first step that we have to go through is compile this program. Compile. So we could basically think of compilation as translation. So, to the computer, like we said, those are just some dead characters on the screen. What the compiler does is that it translates those characters into a readable format for the computer, which is machine language. Okay, so the compiler is just a translator. Then what? What actually happens? Okay, so now let's think about it. What actually happens to this machine language? What happens to the ones and zeros that the compiler generates? Well, we're gonna focus mainly on two components of the computer, the CPU and memory. And the CPU and memory are actually built on combinations of what's called an ALU, memory units, like smaller memory units, and registers. And each of these components are actually built from logic gates. Logic gates. And those logic gates are actually built from more primitive logic gates. An example of primitive logic gates is NAND and NOR. Keep NAND in your mind because we're gonna be using it a lot. And it's the building block of this series. And those primitive logic gates are actually built from transistors. You've definitely heard about transistors before. And those transistors are actually built from... No, we're actually gonna stop here because this is beyond computer science. This enters the field of semiconductor physics and quantum mechanics. Okay, so we're actually gonna go back to the primitive logic gates. What we're gonna be doing is try and build everything back up, starting from a primitive logic gate, like NAND, creating more complex logic gates, and from those logic gates we're gonna create an ALU, memory units, registers, bits, and stuff like that. And using all of that, we're gonna create a CPU and memory and connect both of them somehow to create a fully working computer, hopefully. So you actually find out that the computer is quite stupid. It does not understand anything that it's doing. We have effectively tricked some sand pebbles into doing math for us. It does not understand your print hello world code. It does not understand the ones and zeros. It only does what ever the engineers who made the hardware for it told it that, yeah, that is what you're supposed to do. So it all basically works because a couple of engineers took some wires and wired it in a specific way that made the computer behave in this way. That's it. Okay, so primitive gates. The gate that we are going to be using, and you could actually consider it just a Lego block. So a Lego block that we're actually going to be using to build a skyscraper. And that Lego block is the NAND gate, like I mentioned before. This is the diagram of the NAND gate. NAND. Now you may be wondering, what does NAND even mean? It stands for not and. And what is either of these? What is not? What is and? That will be the topic of our next video, which is gonna cover Boolean algebra. Thank you for watching episode 0.